here. And now this was where I'd asked the students, what could be more helpful. The textbook that the curriculum I was using, the PowerPoints and stuff are a little bit more theory based. And they said it'd be helpful to get more practical based. So that's what this one does. So um, there's actually already a recording here. Uh, I was listening to it last night. I made it while it was raining, so you'll hear the background, the rain quite a bit. But it's still, you can still hear it, but hopefully the rain doesn't throw you off too much. If you click on the slide deck, it does something a little different. Um, it's actually made as sort of an interactive presentation. And so you could pull this up. What it's going to be is we'll be looking at some questions. The calculator's right next door. You might have to sort of resize your window to get them to fit side by side because otherwise it goes below it. But that's how I'm going to do this is do a side by side. As a question comes up, we'll pop it. We'll go through it. And then if we click, it's also got screenshots of the windows of that I'm using. So those are kind of will serve as notes. So when you go back through and you say, what buttons did he push? Okay, then you can kind of at least see the calculator screen and see what I'm doing because that's the key part. Um, as we're going to go forward with this, there's a lot of stuff in this app that it will do, but remembering which part for which questions is still something that is kind of what we're learning. Okay, let me see if I can make it just a little bigger. I'll show you. Nope. See if I go too big, it drops below. So that's about the optimal size for this particular screen. Okay. Um, so we're going to be looking at the standard normal distribution um, and what that means. A normal distribution is symmetric. So this is that bell-shaped type curve symmetry, right? The left and the right sides are the same. And when we talk about standard normal, so just a normal distribution will look something like this, and it'll have the mean here in the center. So I'll put that mu. It's got standard deviations and such. The standard normal always has a mean of 0 and a standard deviation, which I'll write like that, of 1. Okay. So the first part, that's what we're going to look at. The second part, we're going to look at normal distributions that aren't standard normal. So they give us a measurement for the mean, and the standard deviation may be something other than 1. Okay, so we'll look at both of them. Basically, there's the same thing. The only thing we have to change is the first step when we go through this. Okay, so but watch that carefully. When you're reading a question and it says you have a standard normal, it's in effect telling you that the mean is 0 and the standard deviation is 1. Sometimes in the homework it's not going to say that, but if it says standard normal, that's what you know it is, because you'll go, well, I can't do this unless I know the mean and the standard deviation. If they say standard normal distribution, they mean mean is 0, standard deviation is 1. So they've given it to you, but again, in a sort of coded way. So that's sort of the first, I'll say, vocabulary uh, that we have to talk about. So when they say standard normal, that is a particular one with mean of 0, standard deviation of 1. Okay. Uh, the other ones, they will give you the mean and the standard deviation, and that's usually we start doing those, and then when you come back to the first ones, um, you have more trouble. The other thing is, because we have the tool built into the calculator, I'm teaching this differently than I learned it, and a lot of people teach it. They'll use tables to look up a lot of the percentages or formulas to get there. We have it all built in. So um, there's some things we're going to do that are different, that we don't have to focus so much on as many of the calculations. But when we need to do a calculation, we'll do it. Let's see. Click here. Let's see. What's the problem? Okay. Um, so then we'll do standard normal and then just normal distributions where the mean and standard deviation are not equal to 0 and 1. So normal distributions. What we're going to see is in your NumWorks calculator, again, which you can download to a cell phone. You can have it on your computer as well. If you come to this screen, you've got it right over here, and this is a working calculator. It's not just an image. So I can come down here, and usually starts off with calculator, and then distributions is down here. This is the one we're going to be using. And I think we already used it, didn't we? Did we? We did binomial distributions. Yes, or Thursday, Tuesday? Today's Thursday, right? I think we did. Make sure I'm in the right place. Maybe I skipped something. No? Was that familiar with the binomial distributions? Okay. So we're going to use the distributions. And in this time, when I hit OK, we're going to use the normal. We talked about the binomial, and the binomial is, remember, a discrete probability, which means the answers are either 1, 2, 3, 4, they're not anything in between. So binomial is a little different. When we get to normal, we're talking about continuous data that goes through, and so we'll see how it's a little bit different, but very much similar as well. Okay. The first step we get is we have to put in the mean and the standard deviation. It defaults to a mean of 0 and a standard deviation of 1. This is the standard normal. Okay, so for this first part, we don't change that. The only thing that happens in the second part that we're going to look at is we change those to whatever they give us, and it really works the same way. Okay, so we're going to start with the standard normal. So we'll accept those default values, and this is what the standard normal looks like in that symmetrical bell shape. Remember, the shading is the percent of data that is below the curve or at a certain point. So this is telling us that 50% of the data, 0.5, lies between the mean, which is 0, and to the left. So below the mean is 50% of the data, which means how much is above the mean? 50%, right? Because it's 100%. The whole thing is 100%. So that's a key part. This is a probability distribution. Everything adds to 100%. So 50 below, 50 above. 40 below, 60 above. Okay, so those are the kinds of things we can work with. And so that shows that. I may switch over to the calculator that's more full screen, because sometimes on the recording it's okay, you can make it bigger, but sometimes when we're going to look at these, there's actually a zoom feature in some of these applications. Okay, so we have 3 different choices. This is the one where x is less than or equal to 0. Okay, so that's less than or equal to the mean. If we arrow over and hit the down arrow, we see that there's 2 other options. There's one with the shading in the middle, and so that's going to be the probability or the percentage between 2 different measurements, 2 different numbers, and we'll talk about that. And then the third one, this one here, is going to be the percent above. And again, if we do that, you kind of see that's a percent above a number. Okay, and those are the 3 types of questions. Notice there is not, this is different than the binomial, there is not an equals to a number here, because when you have continuous, everything's going on continuous. If you remember from your geometry, a line has no width. Okay, why do I have such a hard time this morning? In the binomial one, remember, there was the data was equal to a particular value, 2, 3, or 4. So in that case, there is something there to measure. But in the continuous case, there is really, if you look at what's exactly at 2, it's a line. There's nothing there. It would come back at 0. So for the distribution, that's the one thing that's missing, is there's not an equal to exactly 2 here, because it doesn't make any sense. You have to have some width. So we have below a number, above a number, and between two numbers. That's all we're going to have with the normal distribution. And that's because of that's one of the properties of continuous, is that there's almost really, you'd say, nothing there exactly at 2. There's stuff below. Does that kind of make sense? Maybe not. How we do it. So a lot of things is what I want to get you into, is doing problems. And for me, that's how I learned. You could talk about theory all day long, and it doesn't make sense until you start doing some stuff with it. And then it's almost like you don't need the theory anymore, right? Okay. So we do one. Just to get this one, we could come over here. Again, we're going to go up to the less than, and we've got x less than or equal to 0. That's the mean for a standard normal distribution. And incidentally, you can make any any normal distribution into the standard normal. We'll talk a little bit about this, but I'm not relying heavily on this because the calculator will handle it. There is a formula, what we call it's a z-score, and z is equal to the data value. So if you have something that is not sort of normally distributed, I might show this a little bit later, but I just want you subtract the mean, and then you divide by the standard deviation. What ends up happening, if you put the mean minus mean, that's how you get the 0. Okay, so if the mean is something other than 0, they can standardize it with this formula. And so you'll see throughout this, we start talking about a z-score. And this is a way of doing the data by standardizing it. And that's been the way statistics has been taught for, well, hundreds of years, maybe thousands, I don't know. But at least certainly within the last 100 years, it's been taught by this. And then you take that z value, you go look it up in a table, because they didn't used to have calculators, right? And even when they had calculators, they didn't always put the statistics in it. So you'll hear me talking about a z-score, and what that is it relates to here. So a z-score of 0 is at the mean. And then in this case, the numbers down here are standard deviations. So this is negative, so this would be 2 standard deviations below, 4 standard deviations below, 2 standard deviations above, and 4 standard deviations above. Okay, so we will use this, but the nice thing with the calculator, since we can change the mean and the standard deviation to fit the problem, we're actually able to use the same tool for something that's not been standardized. So I don't spend a lot of time talking about this, but I wanted to spend a little so that you understand when I talk about a z-score, what we're talking about is specifically if it's related to the standard normal. But we diverge a little bit to get you doing some more real world type problems without having to spend like 2 weeks learning about how to standardize everything. Okay. Keep moving. But if something's not making sense, please let me know, and don't save your questions to the end. It's not an interruption, it's a conversation if you have questions or something doesn't really seem clear, and we'll go there. Okay, so that's the probability below. Here is a probability between two numbers, and they do from 0 to 1. So again, between two numbers, all I have to do is choose the tool for between, and then I can put my numbers in here. So between 0 and 1 standard deviation is 34.13%. If you remember, we talked about the empirical rule, and we said it was exactly 34% just because we were just rounding it. Okay, so the empirical rule says from 0 to 1 would be 34. 0 to 1 below would be another 34. So if I come and change this a little bit, instead of going from 0 to 1, if I went from negative 1 to 1, what am I going to get? Is it symmetric? 34 plus 34 is, you got it, 68. Okay, so you can see now we've got this tool that does a lot of things, and we can get the exact values. So we started with this empirical rule where we were just sort of estimating. Now we've got a tool that will give us exact values, and we get the percent below. So 68% of the population, if it's standard normal, are between 1 standard deviation below to 1 standard deviation above. But notice it's interactive. We can get any values we need. And then I think finally, we're going to take a look at percent above. And again, we could put any value part. And a lot of what the homework is they give us this stuff, and then they're just asking what's the percent above. Cool is next week they give us the percent, and we just need to find the values. And we use the same tool, but we use it backwards. So as you learn how to use this, you're going to become very proficient at doing the statistics, getting the answers for what they are very quickly. And it typically would take, in the past, an additional 2 to 3 weeks of instruction to teach you all these little skills to get these values, but the calculator's allowing us to go further, faster. So hopefully the goal is that it will help you understand what we're actually doing with these numbers, because that's the part that usually gets lost. You spend so much time getting the skills to do the calculations that not enough time is spent on what does it all mean when we've got it. Hopefully we'll get to that part. So again, I for that one, let's see where I'm here. I just have to pull up the tools. Here's the percent above, or the greater than, right? X is greater than a value. And again, 0 to 5, that's half of it. If I change this, maybe going, oh wait, that's greater than 0 is half a percent, or 50%. If I change it, maybe what's the percent above 1? You see it change, and you see the picture here. You see it's a smaller amount, and that is only 15.8%, so around maybe about 16% in that little part there. But notice we can get those values as needed. All we have to do is plug in what will be called a z-score. In our tool, it's saying it's X, but when we standardize, okay? And you'll see when it's not standardized, we plug in the value, the data value that we're given. Okay. So far, so good. So those are the 3 tools we have within one tool. So the distribution, normal distribution, and we set it up. Why is it the standard normal? Because it's got a mean of 0 and a standard deviation of 1. That's what makes it all standard normal. Okay. So that's 50%. And again, as you click through these, if you pull this up, you'll be able to sort of work it on this calculator, and then in a moment you'll see the answer something. I took images because that's the nice thing of Numworks. I can just, when I do it online, you can hit the camera button and it will take a picture of the screen. And so hopefully it'll remind things. So these are types of questions that will come up in the homework. So we're just going to talk through them. Here we go. Find the cumulative area. Okay, so the area, all of the area, just maybe sometimes the language could throw you off, but it just means everything to the left. And I get my left and right mixed up sometimes. That's why I'm not my wife would actually dance with someone else because I always do backwards. So left means below, right? So that's, okay, what tool are we going to need for the below? Here it is. So for me, it's just, okay, that is the left side. It's the below. So I'm going to use, oops, not that tool. Do it again. I'm going to use the below tool. That corresponds to a z-score, and this is why the questions are saying a z-score. Well, what's a z-score? Just a standard normal distribution score. So it's really 1.15 standard deviations is the way we think of it. Will the area be more or less than 0.5? And you kind of think, well, where's 1.15? It's above the mean, right? And we want it to the left. Again, I don't know, let's just see. That's the nice part about this, is we don't have to answer the questions. We can use our tool. So let's come over here to where we put the 1.15. We put that for x. X is going to be less than or equal to 1.15. Put that in. We hit OK, and then we see the move, the shading move. Here's 0. There's about 1.15, and it gives us the answer. The percentage is about 87%, 87.49. And we can get as accurate as we need to get. If I click here, see the same pictures there, so you can see, did I match that up? So if you put in negative 1.15, you'd end up over here, right? Positive 1.15 ends up over there. And so it just gives you a way to visually also to verify things, not just coming up with a number. And like I said, I've taught this with the TI-84 calculator, which has this built in as well, but it doesn't give you the graph. It just gives you the number. And it's so easy to, okay, that was the number. And it might be the wrong one because you put a negative or something, so there's all sorts of errors that can come up here. But when you see the graph as well, that helps you understand. And it helps you understand, yeah, that's a lot of percent of the stuff. It's got an 87% chance of happening if we were to randomly pick some data point out of here. And it also shows you this connection that there's the unshaded region's a small amount, but the two together will always add to 100%. Okay, so it kind of gets, those are the concepts that you're going to get repeated again and again every time you look at that answer. Again, the homework may just ask you for this value here, 0.8749, or it may ask as a percentage, so then you've got to move the decimal over two places, right? Because you're multiplying by 100, 87.49%. Whatever it's asking, we put it in there. So we've got our answer, but this is also a very important part for our minds to catch on to what's going on. Because we visualize when our brain has a picture, it's so much stronger than words alone, stronger than just numbers or letters. It's the way we work. Okay, so far so good. This is all we're going to be doing is we're going to look at questions like find the area under the curve, under the standard normal curve. So that I'm going to back up here a little bit. Standard normal, 0 and 1. Because when we move to the next section, all we're doing is changing those values. It's not been standardized. We're going to put some numbers in there other than 0 and 1. But for standard normal, we just need to make sure that 0 and 1 are in there. Okay. So I don't spend a lot of time going back to this, but I just want to remind you. Standard normal curve to the right. Okay, so that's telling us it wants above, right? So that's where, again, I really like how they did this tool is we've got the visual, there's to the right, yeah, and then you see that means that the symbol is x is greater than or equal to. So it's not just relying on just symbol recognition, but also a picture with it, okay? So we want that in 1.06. And again, this question is to kind of get you to anticipate. 1.06 is above the mean. We're going to the right. It should be less than half because the mean forward is a half. But again, if you're not quite sure, you just put it in 1.06 and you get the exact value. It's only about 14%. We see it here. And then, as you go through and do this, take the time to not just look at the answer, but look at the picture and put the two together and connect that, oh yeah, this is above the mean. It's going to be up here onto the right. And that's about that much percent. And so it all makes sense. Okay. And again, we'll just click over here. And as you do this, you get these answers. That's all you're doing in the homework. This could be the homework question and what we would put in. They ask for as a decimal, 0.1445, or actually the 5 would probably get rounded up 1. Again, our answer is 0.1446. If they wanted 4 decimal places, if they wanted a percentage, we put in 14.46%. Okay, so that's all we're doing. Yes. For our homework, what we have set up, they'll just give you a little box if they. Notice these numbers we're getting are not x values. So these are the percentage or the probability. Yeah, but good question, because on Tuesday we're going to put the percentage in and we're going to get this value. So sometimes we but I believe in the homework they have it set up with x equals to something or something. So, but thanks. I'll take a look. Again, a lot just depends on how the homework asks the question, um, and so I'll take a look at that just to make sure that I give you the information appropriately, because it's nothing more frustrating than putting in a right answer, but it's not formatted right, so it keeps marking it wrong, and you think your answer is wrong. It's just the formatting. So thank you. Uh, yeah. So this time we're just putting that value in. Okay. And while it's not required to, do something with the graph, again, they're there to help us understand this. And in the old ways we used to teach this, we would have been given a value. We would have used that formula to get this z-score. We would have maybe had to draw this little thing and anticipate where it was, and then we'd go look it up in a table. And sometimes in that table, we'd have to add or subtract from 100 because the way the tables. So you can see that there's a lot of calculations behind this using the older methods, but we have this calculator that smooths it out for us. So hopefully, again, the goal is that you can take this statistics class, whatever you're doing. You may not be doing research yourself. You may not be doing the statistics yourself, but I'll bet you each one of you at some point in your life are going to be consumers of statistics. I mean, you already are. You want to lose some weight? Well, you look at the weight programs, you look at the research, which one, they lost this much weight. Well, what's the, how did they know that? They tested this many people and the samples and blah, blah, blah. And this is how they're going to get those. So you're going to be a consumer of statistics at the very least. A number of you this will open up a door, and that's why I think you're very wise to take it at this point. Getting an associate's degree is one of the hardest degrees to get because you've got the first 2 years, you're taking so many different classes. Bachelor's degree is a little easier because all you got to do is finish up your last 2 years, and that's usually focusing on a major that you've chosen. So you're in the stuff you like to do. But right now you're taking stats, which maybe you don't like, or English and writing and this and that. It's the harder part. Bachelor's is not so hard. The thing is, you get to a master's degree, you don't take general ed classes in a master's degree. You focus on your chosen field right away. That was a mistake I made. I waited 13 years to go back to get a master's. Master's actually easier. A lot of master's programs, you don't even take tests. You just do projects and you turn in papers and stuff. Wow, master's was easy compared to a bachelor's degree. And then a doctoral degree, yeah, people will say it's all hard. They kind of make it hard, but it's really not that much harder. It's just that you take what you learned with your master's and you do some research. Exactly what we're doing here, okay? And you use tools to do the statistics to do your stuff, okay? So I just want to encourage you, if you have those kind of dreams, it's all possible. And I held back myself, didn't get my doctorate till I was 61, and it took my wife, who English was not her first language. She was from Thailand. She came here when she was 27, and she finished an associate's degree, got her bachelor's, went on to a master's, and did a doctoral program. Mostly she says, I just wanted to show you that you could do it. If I could do it, you could do it. And I said, okay. Actually, she helped me a lot because my writing skills are not as strong. Her grammar was really good. So a lot of times international students who English is not their first, they understand grammar better than those of us who English is our only language that we use. So anyway, I digress, but let's get back here because we're actually almost done. Get rid of those things. Okay. Again, just some more samples. How do we find the area of the standard normal curve between two values? Again, not a lot of calculations to do. It would be if we were doing this by hand and looking it up in a table, and we'd have many calculations. For us, we just go to the picture that looks like, hey, that looks like area between two things, right? It's the middle part. So I choose that as my tool, and I'm getting something here. And then here's my two numbers. And notice I've got a number here less than or equal to x, which is less than or equal to that other part. So this is where I put my two numbers. The only thing I have to remember is put the smaller number first, so negative 1.5. Yeah, it's hard to see this one. And then I come to the next number and I put in positive 1.25. And again, that's why you'll see this picture. It'll make more sense. I hit OK, gives me my answer. And here's a bigger version of it. I'm just having to put those two values into the tool. Okay, and my answer, what do I write down or what do I put in? Typically, they've asked for what is the area? Well, find the area. What is the area? It's 0.8275. Or if they want it as a percentage, then usually if they ask for the percentage, they would have asked what's the percentage. It would be not zero, it would be 82.75%. So watch for that. Usually in the homework system we're using, they will, if they want a percent, they'll already include the percent at the end of the answer box. So you'll see that little percent there. Oh, they want a percent. If it's not there, then they're going to want the decimal. Okay. But notice it was just plug it in and get the answer. Again, the TI-84 can do all of this, but the thing you miss in the TI-84 is this picture, which again, when I was learning this, I had to draw it by hand, but it's so much nicer having the tool draw it because it's going to be accurate. Because sometimes you're just learning, you're not quite sure, but this reinforces we're getting the area between these two. It's shaded. There's these areas that are outside that, because after this next test, we do something called hypothesis testing, and we're looking for something. We're doing a treatment that our treatment had an effect. That means that we're outside of we're in those, what we call the tails, right? We're in this unshaded region. So right now we're looking, the usual stuff is in that shaded region. That's what happens the most. But we're also going to talk about what's in the tails, because that means if it's unusual, maybe our treatment has made an effect. We're actually curing cancer. Cancer's not progressing. We were able to stop cancer progression or something. That's what the statistics are going to allow us, maybe not to prove, but to see that we're on the right track, that what our treatment is doing is making an impact because we're getting unusual results. Okay, so that's the two things we look at. We look at the usual, which is in the middle, and often the research is we want extreme things because that means what we're doing is making an effect. It's changing the world. They always told us, don't try to change the world. Why not? It needs to be. If you don't try, you can't ever get anything done. Let's see. See, I told you, it didn't have much time. You're ready to do all that homework on standard normals. Not only that, I'm going to show you the one thing we need to change to do the homework that is not standard normal, and it's real easy. It's the same stuff we've been doing here, except we're going to go back here. We're going to change these numbers to what they give us. And then everything we've been doing is exactly the same. That's what I like this tool. It's has a quick learning curve, and then we're getting the pictures with the numbers, and we're seeing what, everything's connected. So that's why I could take a break and you go through things, but I just want to show you that there's not much left. So we're going to go to the next step, and then we'll take a break, and you'll be able to do at least the first 10 homework problems in chapter 6, and we'll give you the rest of the time period to work on that. So you have about at least a full hour to do that. And then on Tuesday, we'll pick up a couple other concepts using the same tool, but practice this tool. This tool, I can't say it enough. It's just amazing that it will help you to actually understand statistics, not just do statistics. I did statistics several times in my career, but I'll be honest, I really didn't understand what I was doing. I could get the right numbers because I memorized the calculation steps, but it took me until into my late 50s before I started to be able to understand what it means. Okay, so here it is if it's not a standard normal, what ends up happening is they haven't standardized it. These numbers, and actually this is a better way to do it, because the numbers they're going to give us is actually relates directly to the data. Okay, so a random variable x is normally distributed. Okay, we need to know that. You'll see that a lot, because if it's not normally distributed, we can't use this tool. So it has to be something that is normally distributive, so symmetrical. And there's a whole lot of research that goes behind that. they'll give you the mean. The mean is 81, and they'll give you a standard deviation. So remember, 81 is a number that's a data value that's going to be in the middle. It's the mean, and that standard deviation of 5 is a standard step. So it would become a standard score of 1. So 81 to 86. But watch what happens. This is the cool part. I just enter it here. So I put in mu is 81. That's on mean. And our standard deviation is 5. And watch the magic that happens. When I do that, our standard normal curve now does not have 0 as the mean. It has 81 as the mean. Although it says 80, but it's just a little bit off the course. So sometimes the number line they use doesn't match up. But notice these are actual data values. So if I knew what my data was talking about, I get numbers that relate me directly to the data. I don't have to go through this process of standardization, look up the value, and then go backwards to it, okay, which is a lot what we used to do. Now we can just go directly from our data to analyze it and get our questions answered. Find the probability that the random variable, the data, that we have a data point that's less than 76. And again, you'll start to picture it. 76 is on the left side of 81, so it's going to be less than 50%, right? You can at least see those kind of things. But all we have to do is we just need the less than tool, which is what we've got, right? Less than, between, greater than. So there's the less than tool. Come over here. Now we just put in 76. We do not need to calculate a standard score, which was the old process, and still taught by many. But with this calculator, with this tool, we put it in, we see the picture. I'll give you the bigger picture over here. Put in the 81. So I put all the reminders. If you go through this, it's how did you put in the mean and the standard deviation first. We come over here, we put our 76 in here. We've got our answer. Find the probability. It's a probability of 0.1587. We'll round it using 4 decimal places. Or if they ask for a percentage, we could do it as a percentage, move the decimal over 2 places. So that's 15.87%. Or if they want it rounded to just 1 decimal place, 15.9%. So again, those are the things but I just put that answer in. So notice all I had to do is make sure these numbers are what they gave me, put them there, put this number in here, and it gives me my answer. But it also shows this, which again, in the old days, last year, we'd have to draw this by hand to kind of get that understanding, but it's giving it to you all at once. And again, a lot of other calculators will get that percentage for you. It's a little bit more learning curve and you have to get everything in the right place. It's more like programming, but it doesn't give you directly that graph. So that's why I like this calculator a lot. I think it's worth it. Okay. And we'll see. We've done all of this, right? Now, assume the random variable x is normally distributed. You'll see that just, kind of phrase, that's required because if it's not, then we can't do this. So it's just saying, hey, you can use your normal curve. We're given a mean of 50, standard deviation of 7. Again, this is tied directly to the data. So all we got to do is with these ones, each time we just have to go change these numbers. 50 for our standard, our mean, standard deviation of 7. And again, as you see these numbers, average, the middle is going to be 50 plus 7. 57 will be a 1 standard deviation. Just kind of get thinking along. But see, without having to do all these, now how do I calculate all this stuff? We're taking that off of your plate, off of your brains, not having to deal with that. It just does it. Okay. So we get it set up. We got everything here. What's the probability x is greater than 43? That's going to mean to the right. But see, with this symbol, we can come here, this symbol, we're going to have to change it to be greater than. Now, I didn't speak too much, but the calculator always does greater than or equal to. If you watch the video I did talk about, notice they're usually just saying greater than 43. The thing is as I said, being equal to 43 is actually a 0 probability. with when we talk about continuous data, because a line has no width. Okay, so that's why when they're even if they're asking x greater than 43, it's really the same. You're going to get the same answer as if they ask s greater than or equal to 43. But mostly they'll say that the calculator has this greater than or equal to symbol. So if that causes you some dissertation or some concern, that's good because you're looking at the symbols. But just remember that in this particular case, because it's continuous data, being equal to a number is always 0. You have to be either below it, above it, or between two numbers. Okay, and so we just put in the 43, and we get our answer. Again, I'll click over here so it's easier to see. We put in, again, the reminder, you always have to change that. If you don't change it, then you're doing some other problem, and that's, but the thing is if you forgot to change it and you put it in, the graph will probably say, wait, that doesn't look right. Oh, I forgot to change the mean and the standard deviation, so it's not set up right. You always have to do that step first. And then we come here, it's 84%, right? So again, depending upon how they ask for the answer, they ask for just a decimal, it's 0.8413 to 4 decimal places is usually what they would do because that's how the tables had it. Or turn it to a percentage, move the decimal over 2 places, it's going to be 84.13% or 84.1%, depending upon how many decimal places the question asks for. Okay, cool. But again, we get to the answer really quickly. But again, we also see, yeah, that looks like about 80. That's a big match. That's 84. What's the percent below? Again, if you use the other one, it's just a little bit. Okay, so sometimes you've got to remember to change the tool, but this system will help. It will teach you why you're using it. That's why I do it. It's not just to get an easy answer, although that's nice, but it teaches you as you use it. If you will do those two things, look at that answer, look at the graph, and you'll just naturally say, yeah, that makes sense. 84%, a lot of yellow, a lot of gold. Gold is better than yellow, right? Okay, get that out of the way. I think we got one more, and you guessed it. So this is going to be like how a question might be. And again, there's all these different questions, but you're going to see it's really a quick answer between all of these. So we're given monthly utility bills with the city are normally distributed. That part is just saying, okay, you can use the normal distribution with a mean of $100. So the average is 100 that people spend. Standard deviation of 15. Okay. So again, we come here, we set up our tool with the mean and the standard deviation that they gave us. And again, we spent time calculating those before, but we'll see when we get to this place, they're not going to give us the data. We could, if they gave us the data, we could calculate these values, but in this steps, they're going to give them to us directly. We're not having to do the calculations, although we could. Okay. So here it is. And yeah, hundreds in the middle there, sort of. It doesn't really show up. Now find the probability that a randomly selected utility bill is less than $67. So what's the probability of getting less than $67? Again, all we have to do is come here. We've got our 3 tools. We want the first one. That's the less than, which is usually the default. And then we don't have to do any calculation. We put in 67, and it's going to be dealing directly with the data, so that we're also getting, and it looks like, a little bit. So it didn't do anything. Oh, there's just a little shading down here in this corner. And again, I'll click over here, set that part up. And the first answer, yeah, it's just a little bit of shading. And you see it's less than one, it's 1.3%. That's why probability of getting that bill, maybe they have the tiny house or something, but here in California, I know it's more expensive here, but electric I found was 3 times more expensive than in Phoenix. 3 times. I looked up the cost per kilowatt hour, and because my first month here, it was my bill was $300, and I live in a small RV. It was because I was using my space heaters, and usually it would have been about $80 when I was in Phoenix. Maybe it would have been $100, which I was cold, so I was happy to have some heat. But I didn't think it'd be $300, so I had to go get some propane the next month. I didn't, I said, I know it's a little more expensive. No, it's 3 times. Your electricity here is 3 times that of Phoenix. And Phoenix isn't necessarily cheap. I grew up in Oregon and we have hydropower. It's really cheap. But anyway, I diverge. Okay. So again, you'd put this, this is your answer right here. So we enter that as a decimal or as a percent. So that's, there's still some math involved. It's 1 point, maybe 1.4%. We round it depending upon how they want that answer, or maybe they want a 0.0139. Again, however they ask for it, but this is our answers right there, and we see it. Between these two numbers, so this one question, we're going to use all the tools. We just come down, change the tool to between, and we enter the two values they gave us. 88's lower, so we put that first, and then 120 is higher, so we put that. And again, it's going to give us the picture. And so, but watch it, look at those pictures, because again, between putting in the values, looking at the picture, and even if you didn't try to anticipate, your mind probably is thinking ahead, and it'll either match that or it won't. But as you look at that, the more and more you're doing that, you are learning the connection between those values, the mean, the standard deviation, and the answers you're getting. And again, this is 69%, almost 70% of the data would be between those two. And again, it all depends on house size and stuff too for your particular one. But if we took all the data, these are averages, and then what would be the probability that's going to be more than $130? Well, again, we just have to use the other tool, which is the greater than. And for that one, there's only one number to put in. What do we put in? 130. And we get a very small value, just like we did on the other, but we get it up at the higher end. So about a 2.2, 2.3% chance if we round it, right? And this was about a 69.7%. And again, getting the answer here. Here's our answer. But again, the pictures are there that are so helpful. And I guess that's, like the other calculators, TI, they've got a feature that you could put those numbers in and it would give you the value, but it doesn't give you the picture. I say, all you need is the value, but the picture helps you understand that value. And it shows us which tail we're in. We're in the lower tail, or we're in the upper tail, or we're in the middle. So you get to see all of these with it, and you don't have to go use the z-score here. Like, again, for most parts we do, you would need all that. And I think this is our last slide. Maybe there's one more. I thought there was 9. Yeah. So one last one. But you're going to see this is not anything different. So we'll just kind of go through this. Use the normal distribution to the right to answer this question. So we've got this. What percent of the scores are less than 19? Here's 19. We see the picture. We could figure it's going to be less than half, but I can't get it exactly. But I could use the picture, and I could just go back here and say, okay, they told me the mean and the standard deviation. And again, I don't have to worry that there's decimals involved because I just have to enter it correctly, 5.4. So on average, score is about 20.2 plus or minus 5.4. That's what I'm thinking. I get to my standard, or not my standard normal, just to my normal distribution. And I want less than 19. So that's the first one, right? That's the less than. I put in 19 and I get my answer. I put that in, got my answer, and I see the picture. See, it's matching. This would be less than 19, about 41.2%. That's all the answer I got to put in there. And again, if they ask for it as a decimal, that's the thing, is what format do they want the answer in, but that's it. Now, this one's a little challenging. Out of 1,500, 1,500 randomly selected scores, about how many would be expected to be greater than 21? Greater than 21. Well, first we have to find the percent that would be greater, and then, but notice they want how many, not what percent. So This one we have an extra calculation, but not too bad. We just go down, we want greater than 21. So we come here, we put in the 21. And we see that we're getting the percent greater than 21. I'm going to click down here because it'll be easier to see. And there's 44% that are greater than 21. So this is not exactly symmetrical, right? 21 is a little different. It's 44%. And so what I need to do with that, we were doing this earlier when we were talking like relative frequency and stuff. I need to take the 1,500 randomly selected scores, and I need to say 44% of those, or 0.4411. We'll do 4 decimal places. I just need to multiply these two, and that will give me the number. Okay, so sometimes there's that little calculation in there. And again, I don't have a special feature. It'd be nice if I could put something in there, I guess, and just change this to from percent to amount. But what I'm going to do is just go back to, this thing has a regular calculator, as I call it. So I just type in 1,500 times 0.4411. And I find that that is 681.6. And again, you don't get 0.6 of a person, so we round it up to 682 is how we would answer that one. So there was a side calculation needed for that. Occasionally there is. We're always getting a percent. And then if we need an amount, we multiply. Make sense? So there was 9 slides. This is the last slide. So we just did 2 sections within the 1 hour time period, which will leave the rest of the time period available to you to start working on the homework and using this tool. Okay, so that's, you'll see that for the most part it's in there. There might be a few things that we have questions on, but that's why we're here. Okay, so I stay here. I got no place to go because I got a class at 11, so right in here. So that's why I'm always here. But again, you can do as you like, but we just start working through about the first half of 6. When you get to questions that I didn't think you'd talk about that probably means that's what we're going to talk about on Tuesday. Okay, questions? Yes. Okay, you got it. Let me